Hello, I am standing below Pete's Hill right now, and we can easily see some processes by which soil is formed and eroded. If we look up top, we can see some vegetation which has rooted and is helping to hold against the obvious signs of erosion. From this fluvial carved area, which we can kind of tell from some of the more rounded stones, and the rockfall from the steep slope, as you can see with the white rocks, we can tell from these angular stones that have fallen down to where I am standing. The production of soil that we can see here is depth dependent. And we can see the mobile regolith on top is produced by chemical weathering, which releases rock-derived nutrients that weathers away minerals and decreases rock coherence, and physical weathering that loosens individual mineral grains from bedrock. For soil conservation to occur, we need a balance between erosion and soil production, which we can also predict and derive through the equation dH/dt equals P minus E. And the P soil is the long term and E is the short term erosion. And soil production is a long-term process, and erosion is not always necessary. There exists both positive and negative relationships between erosion and production. If there is a relatively low thickness in the soil, there's actually a positive feedback that increases thickness as soil produces. But there is a point when this changes to a negative relationship that is stabilizing and creates soil conservation. In this system, it looks like to me that this is in that negative relationship because of the larger thickness, because we're standing pretty below those trees up there, and is decreasing soil depth from erosion.